Lystrosaurus was a genus of heavily built, burrowing herbivore that lived from the late Permian to the early Triassic. There are currently believed to have been 4 species of Lystrosaur, although studies in the 1930s and 70s claimed around 20. They ranged in size from 0.6 to 2.5 metres depending on the species. During the Triassic, they reached across most of the supercontinent Gondwana, and their fossil remains have been found in India, Antarctica and South Africa. Lystrosaurs possessed no teeth, and instead ate using a pair of tusk-like canines as well as a horny beak. This allowed them to feed somewhat like turtles do today, but the most common analogy made, despite being somewhat unflattering, is to pigs. So why am I telling you all this? Because although Lystrosaurus seems incredibly unremarkable, it did something extraordinary. During the early Triassic, 90% of land vertebrates alive were Lystrosaurs. They dominated their ecosystem in a way that had never been seen before, and will likely not be repeated. It started with them surviving the end Permian mass extinction. This was caused by huge amounts of volcanic activity occurring in the Siberian traps, and it left behind an ecosystem that would take 30 million years to recover. 95% of species alive were wiped out, so Lystrosaurs surviving wasn't exactly easy. But why was it Lystrosaurus that not only survived, but flourished? Surely, to dominate the landscape in such a huge way, they had to be the most special of super special snowflakes, right? There's been a few attempts at an explanation. One theory is that they could have been semi-aquatic, but when the evidence that seemed to point to this was later looked at in more detail, it was decided any adaptations that could have helped Lystrosaurus in the water were more likely there to support Lystrosaurus's burrowing mode of life, and besides, if being aquatic helped a species flourish, surely it should be an amphibian we're discussing, and not Lystrosaurus at all. Fossil beds from the time do show amphibians becoming more dominant during the early Triassic, but not at all to the same extent. A more recent theory suggests that the extinction event led to an atmosphere reduced in oxygen and increased in carbon dioxide, not to mention the dust and contaminants present after the eruption. Lystrosaurus had short internal nostrils and a large barrel chest, evolved to help with burrowing, but that could have also helped make breathing easier in the new conditions. However, other dicynodonts from the time have similar sized chests, so it can't have been that. The actual reason may be entirely less exciting, that life, and what survives an extinction event, is often a bit of a lottery. Lystrosaurus did not live a life of specialism. It most likely ate what plants it could find, so losing a single food source wouldn't have been catastrophic. The largest known species of Lystrosaur would have needed to eat exclusively larger plant species, and this is commonly cited as the reason for its extinction, unlike its smaller relatives. The extinction event also led to a world with practically no predators large enough to eat a Lystrosaurus, and very few species occupying a similar niche to Lystrosaurus. So without the threat of becoming something else's next meal, any real competition for the niche it occupied, and very few threats on its diet, Lystrosaurs flourished and dominated the landscape in a way life has yet to repeat. But more than that, chances are Lystrosaurus was just plain lucky. It existed at the right time and remained small enough to not need too much food in a barren landscape, and yet was large enough to not have any predators in the post-extinction world that were big enough to eat it. So, in the end, it wasn't extraordinary adaptation that kept life going through the Permian. This time it turned out, evolution favoured the humble generalist.